In the last video, we talked about line integral to variables. So now we talk about three variables. If you're just keen about just learning this, or in terms of exam questions, this video is suitable for you. But if you want to learn two variables, I would just recommend you go back to the one that I've just finished. Alright. Otherwise, you can just go to Khan Academy and understand the very concepts of how the graph looks like and things like that. So to start off, we have these questions to ask you evaluate the line integral x squared y ds along the path defined by pair of parametric equations x, y, and some t value between some coordinates. And why is it three variables is because we have x, we have y, and we have t. Previous video we only have x and y only. So in this case we're gonna talk about three variables. And graphically you can see that this is some sort of a graph like that, right? And therefore if I were to take this picture and then I take just a slice of it, I don't know where's my pen, but yeah, okay. So just take one slice of this, right? I'm just taking this slice, and then I just bring this whole slice over here, okay? So at this point of view, alright, you're looking into this. For example, if you're like sitting in a computer and then you have a screen, so you're looking onto this thing right now, you know. So I'm just taking this plane that I've just drawn and project it to you in this manner, alright? And therefore there will be an axis because we are talking about some axis, right? For this axis and this axis, right? Hope you can see. So I'll just brighten up the color. This two axis. So I'm just talking about that. Alright, so when having this thing, you're taking about some line. As you can see, there is some curvature somewhere. Alright, there may be some curvature somewhere. Right? And therefore if you were to go 3D, then you have whatever thing that you know kind of like zoom out like that, and then the shape that is being shown over in the plane. So I'm simply taking out this line over here, this curvature, right? At least you know in 3D how it's being shown. Like, so I'm just taking one slice of it and just taking that line. So this is a line, and I'm gonna integrate a little bit by a little bit by a little bit. Alright, so how do I do that? I've already said it in the previous video, but I'll just say it now again, is that you have Pythagoras theorem, right? Imagine this is ds, this is dy, and this is dx. To solve for ds, you need to find what it comprises of, dx and dy, right? The things that comprises of. And therefore using Pythagoras theorem, you would have dx squared plus dy squared over square root and then ds, right? And then this whole thing, never mind, first like that. Okay, so this is the Pythagoras theorem, right? But something different from what we have said earlier, if you happen that you watched the previous video, is that instead of we divide by dx, right, we now divide by dt. So we're gonna integrate the whole thing by time, because the question asks us to do that, right? Because we know that there is three variables. X and y changes with time. X changes differently, y changes differently. So we're gonna deal with them differently too. Alright? And therefore what we need to do is to find what is x and y. Alright? But intuitively, just want to let you know, at least you get to know what I mean, is that since we have the Pythagoras theorem ready, we are just integrating in terms of this part, this 1 ds by ds by ds, all the way along this line. So let's say I have this thing is coming down over here, it is also comprised of y and x. And if you have this slope over here, it is also comprised of y and x, but in terms of different gradients and stuff like that. But ds is all along this path, and that's all it is, right? It comprises of many small ds's. Alright, hope you get what I mean. And therefore what I can do, since I say that I differentiate in terms of dt, is that I just divide by everything by dt, which is what we, because for example if you want to differentiate dy, you just divide dx, right? If you recognize this is differentiation. If you don't, then this I'll just inform you that this is a differentiation, right? And therefore if I want to differentiate ds, I'm gonna differentiate in terms of its time, and therefore if I were to multiply it in, I would have this form, right? So this dt, so how I derive is that I have equals to, and then this whole thing dx squared plus dy squared dt, right? And then the next step is I just bring this into this. Alright, so what I do, if you remember the previous video, we have also said that square root a divided by b is equals to whole thing square root a divided by b squared. I have proved to you that. Please remember this algebraic method of solving things. And therefore if you were to do that, instead of a, maybe you can say that a plus b divided by c, and therefore the whole thing a plus b over c squared, which is also equals to a over c squared plus b over c squared, right? You just work it out. This algebra should help you to solve into this thing. So this is how I solve for where I am here today. I mean right now, yeah, this formula it is, right? And therefore I'll just bring this dt, I'll just bring it up over here, just multiply both sides by dt. I hope you like seriously. Okay, so therefore you have just earned yourself a new formula, ds, wow, that's great, minus plus, yeah, plus. Alright, just to, before I just provide you with the new thing, and just write it like that. Alright, dx dt. So I'm just taking out the brackets, right? I'm just taking all the squares out, you know, and therefore, and then dt equals to ds, and therefore I have introduced you to a new equation for 3 variables line integral, right? 3 variables. I hope you get what I mean. Yeah. And therefore, this is the formula. And how do we utilize this formula for our line integral? Right? You see that this is a ds over here. So I change ds in terms of this thing. Alright? I mean this thing to simplify it. So I'll just place this question and let's yeah. And then I'll just make it a slightly little small, at least you will not take up my space. And then I'll just, alright, and therefore as you can see, we can just replace ds by this dude over here. My pen is something wrong, but it's pretty fine. So I have x squared y, ds I'll just replace as dx over dt. Yeah, and therefore this whole thing is just ds, which is what the question is. I'm just replacing ds as this one. Just simple as that, right? And therefore now you're gonna solve for dx over dt and dy over dt. So as you can see, we have some x equation and y equation. You just differentiate. So dx dt in this case is just 1, because t plus 1 if you differentiate is 1. I hope you really know what is differentiation. If not, I will recommend you watch differentiation. Just type differentiation, you will know that video, you know, just learn, right? I think that you are at the level to do differentiation. So yeah, anyway, so if you divide it, when you differentiate y, you get 3, right? 3t, you differentiate, you get 3. Therefore I'll just sub it in, just sub in all these values, and therefore I have this one, right? So this thing is x squared, because I'm subbing as x, right? Because it's given in the question. And then 3t, it's this one, y is also given, y is equal to 3t. Please remember to sub in all these stuffs, alright, before you integrate. And then I'll just sub in the one that we have just found, dx and dy's. Therefore we have this one. and just to I'll just rearrange and clean things up. So I'll just try to, expand on this and things like that, so at least you can see what I'm trying to do later. Hold on. So I'm simply expanding this into here. Alright, this whole thing is exactly the same as this. Alright, and I'll just keep this one first. Later on we'll just multiply in, and then I just solve for this. Right, and this is just some constants. It's without any coefficient t, right? And therefore what we can do is to just factorize out this thing. You just do this because it's just some coefficient. We don't need at all, just to make things more complicated. So we just bring it over here, and I'll just multiply in this 3t, right, into all of these terms. So what I would have is this thing, right? Now we need to solve for the definite integral, because they ask you to define the pair, along to evaluate the line along the path. So you're gonna find the distance where you're gonna find the one that I've just drawn just now. I told you this line. You're gonna evaluate what is the distance, what is the quantity move, I would say. So we're just trying to find that, right? And therefore what we can do, because we know that there is x and y that is given over here, and we can just utilize what we need, what we have. So for example, if I were to sub in when this is x, this is y, right? This is another x, this is another y. So I'll just sub in this thing as x. So I'll just sub in both equations. So for example, if I have 1 is equals to t plus 1, so this is x. I think I'll just use a different color. I think this is a not very nice color at all. So just write x is equals to add t plus 1, which is what we have over here. And then I'll just sub in x is equals to 1 equals to t plus 1. And therefore we will know that t is equals to 0. Right? You can also reassure, and then you sub in these values into here, and then you just check it out. T equals to 0 also, right? You can just sub in into one equation will do. Next, sub in another coordinate into any of this equation. So if I sub in x, so again instead of 1 I sub in 2, because this is 2 over here, x is equals to 2. So 2 is equals to t plus 1. Therefore we know that t is equals to 1. Alright, if you don't know what the hell am I talking, I'm just simply subbing in the coordinates into the equation and find for t, right? I can also use y, sub in it into this equation and find for t also, and the result should be the same. They should be equals to 0. For example, y is equals to 3t. If I sub in y is equals to 0, which is shown over here, if I didn't, everything's kind of messy, but you see that y is equals to 0, so I just sub in into this equation as y is equals to 0. So y equals to 3t, right? Y is equals to 3t, this equation. And if y is equals to 0, then 0 is equal to 3t. And therefore, for only the case that 0 equals to 3t, this means that t is equals to 0. And therefore, this also support the evidence of what we have just done earlier. So simply said, we're just finding t itself. We're just finding two t's. Alright, two t's, 0 and 1, using two coordinate system, and that's all it is. So this is generally how the parametric equations concept works. So I'll just write it down, this thing, 0 and 1, and then I can integrate. And I would highly, let's do together, at least you get a feel of the integrations if you have something that is rusty. So therefore, if I were to integrate this thing, alright, I would have, I think I'll just do it together like here. And therefore I'll just, maybe I shouldn't put in the integration, but 3t cubed, if you integrate, you would have you have 3/4 t4, right? You just plus 1 and then divided by this thing, 3 plus 1, which is 4, you get what I mean? I think you get what I mean. If not, then happy birthday. So what I do, same thing for here, I'll have 2t cubed plus 3/2 t squared, and then from 1 to 0. Alright, so I'll just sub in 1 will do, because I'm just integrating the definite integral. If you don't really know what is this, then good luck, you know. So I'll just, since in case you really don't know, so at least you don't waste your time over here, I'm just taking this minus this, right? You may wonder why am I doing that, because I'm subbing in this as t equals to 1 and subbing this as t equals to 0, which is definite integral from 1 to 0, and that's the meaning of that. Alright, so when you have a graph from this is t and this is some value, I call it s first, but it may not be s, okay, it just may not be s. And from t equals to 0 and 1, we're just integrating along this section. Alright, so we are just integrating along this section. The rest we do not care all this, right? We do not care, we're just integrating what is required, that's all. This is definite integral. If it's indefinite integral, then you're going to talk about the infinite line, you're going to talk about the rest of the line, and then whenever you sub in your definite points, if you want this, for example, you have infinite line, and then if you want this portion, then you just sub in your values over here as some maybe 3 and 4, and then you just solve for this thing, this distance, right? Hopefully it doesn't confuse you anything. But therefore, if you were to do that, not forgetting that we have a square root 10 outside as a coefficient, and this thing will eventually become 0 because everything is 0, 0 and 0. If you sum all zeros together, you have a very big nice 0. So we just care about this dude over here on that side, right? Therefore we have 3/4 plus 2 plus 3 over 2 square root 10, right? When t is equals to 1, because everything, this is 1, so I think you get what I mean. Just check it out, it's pretty straightforward. And therefore what you have, to do it out, just type it inside the calculator. You would have 13.439, which is approximately, very highly approximately 13.44, and this is your answer. So just to summarize, this whole line integral series is just integrating along this line, right? Just integrating along this little lines. And if it's two variables, then you're gonna use ds equals to, I shouldn't write this. Yeah, this should be nice. If it's two variables, you're gonna divide by dx, and eventually you'll get ds is equals to blah 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 blah. Alright, this is for two variables. Alright, and if you're interested in three variables, which is what we have just done earlier, okay, I repeat again, this is just as we have done earlier. We just divide by dt, and if you get divided by dt as what we have just derived earlier, you would have this formula. Let me just paste it over here. You just have this one. This is three variable. You just kind of compare. You have dx, you have dy, and you have dt. This is only dy and dx only, right? Two variables is dy and dx. Three variables, you have another extra dt over here, and it's based on what you divide, right? This whole thing is just a Pythagoras theorem. So it happens that if you forgot what the equation is, and you find that, or you feel that this equation is like, what the hell is it, then you just memorize from here, and at least it's pretty much intuitively downloaded into your mind. And I hope that it helps, and I shall see you in the next video for other stuffs. Goodbye.